Hey everyone, and welcome. Today, we're diving into something that is absolutely critical to the future of artificial intelligence: memory. It's the secret sauce that turns a basic program into an intelligent agent that can actually learn, adapt, and, grow with you.
So, let me just ask you this. What if your AI had the memory of a goldfish? Seriously, imagine every single time you talked to your assistant, it was like you were meeting for the very first time. It wouldn't remember your name, your preferences, not even what you just said 2 minutes ago. That's the exact goldfish problem we're going to break down today.
So, here's our game plan. We'll start by digging into that goldfish problem. Then, we'll look at the two big types of AI memory: the now memory and the forever file. After that, we'll see what happens when they team up, and finally, we'll peek at the challenges and what the future holds.
All right, let's jump right in. Section 1, AI's goldfish problem. This is all about why memory isn't just some nice-to-have feature. It is literally the key that unlocks real intelligence in these systems.
You see, without any kind of memory, an AI is basically stuck. It's trapped in this endless loop where it can react to what you're saying right now, but it can't build on anything from the past. It's like hitting a reset button after every single interaction. There's just no way to learn or evolve. So, why is this memory thing so critical? Well, it's the foundation for pretty much everything that makes an AI feel smart. It allows for contextual understanding, so the AI knows what it means when you're talking. It's how it learns from experience, how it makes better decisions, how it personalizes things just for you, and of course, how it keeps the conversation going without getting totally lost. Okay, so let's get into the first type of memory that helps solve this. This is the now memory, otherwise known as short-term memory. It's all about how an AI thinks in the moment.
I think the best way to picture short-term memory, or STM, is as the AI's mental workspace. It's kind of like its own personal scratch pad, holding all the relevant info for whatever it's doing right now. It's active, it's temporary, and it's absolutely essential for a coherent conversation.
The thing about STM is that it's lightning fast. It holds the last few things you said, which in the world of large language models is often called the context window. This is what keeps the conversation flowing smoothly. But, and this is a big but, it's volatile. Once that chat ends or the context window gets full, that memory just disappears. You've probably seen this yourself, right? You're talking to a customer support chatbot. It's using STM to keep track of all the details of your problem right now in this session. But the moment you close that chat window, poof. As far as the bot is concerned, that conversation never even happened. So if STM just vanishes, how does an AI ever really learn? Well, that brings us right to Section 3, the forever file, or long-term memory. This is where an AI actually starts to build a real, persistent history. Long-term memory, or LTM, is pretty much the exact opposite of volatile. This is the permanent storage that sticks around session after session. This is what lets an AI remember facts, your personal preferences, and your past conversations. It's what creates that sense of continuity, what you might even call lasting wisdom. The real power of LTM comes from a couple of key things. For one, it's persistent. You can restart the system and the data is still there. It's also searchable, often using some really clever tech like vector databases, which lets the AI find memories based on their meaning, not just keywords. This is the secret to building user profiles that enable true, long-term learning and personalization. The perfect example of this is a personal assistant. It doesn't just help you in the moment. It remembers your kid's birthday. It knows you like your news summaries as bullet points. And it recalls your favorite sports teams for the next time you chat. That's LTM in action, turning a simple tool into a genuine partner. Okay, so we've got STM and LTM. We've looked at them separately, but here's where it all clicks. The real magic, the real breakthrough is what happens when these two systems work together. It's this amazing synergy of now and then. It sounds pretty straightforward, but you can't overstate how powerful this is. The giant leap toward more advanced AI happens right here, when that immediate, in-the-moment awareness of STM starts collaborating with the deep, historical knowledge of LTM. So let's just put them side by side. On the one hand, you have STM, that's your immediate awareness, the mental workspace. It's volatile and thinks in the moment. On the other hand, LTM, that's the lasting wisdom, the persistent storage. It learns over time and is totally searchable. One handles the right now, the other handles the big picture.
Let's make this super concrete with an AI personal tutor. Okay, first, the tutor dips into its long-term memory to recall that, hey, you've struggled with fractions in the past. Then it uses its short-term memory to track how you're answering questions in today's lesson. Finally, and this is the key, it combines both. It adapts its teaching style in real time based on its long-term knowledge of you. That is truly intelligent adaptation. Now, as incredible as this combined system is, it's not a solved problem, not by a long shot. And that brings us to our final section, the challenges we're facing today and what's next for AI memory. Honestly, building these memory systems is a massive challenge. You've got huge scalability problems. I mean, how do you store and search all that data quickly? Then there are the massive, critical privacy concerns. And on top of that, you have these really subtle problems, like how do you teach an AI when it's okay to forget something? And how do you make sure its memories are real and not just made up hallucinations? But the future here is wow, it's really exciting. We're moving toward a world of user-controlled memory, where you get to decide what your AI remembers. We're going to see much smarter retrieval and even something called memory distillation, where an AI can summarize its experiences to gain new insights. Ultimately, this is what leads to AI becoming true, persistent, and evolving companions in our lives. And that really brings us to this final, really profound thought. As we build AI with more and more sophisticated memory, we have to remember that we're not just talking about data storage. We're building a reflection of experience, identity, and even intention. And that is what could finally transform a machine into something that truly understands and works alongside us.